Good afternoon. Traditional recovery is broken. If you got the AFCOM report last week, this was very clear. Just last week, the state of the data center, you know it's broken. AFCOM found over 15% of data centers had no recovery plan whatsoever. And of those that did have a recovery plan, over half had a plan that was not sustainable. There was nothing in place to address damaged equipment or fallout for the disaster. Of those that have them, you have to wonder how realistic those recovery plans are. A traditional recovery is complex, so some people skip the planning. Traditional recovery is expensive, so some people skip the investments. Complex and expensive. This makes traditional recovery the ideal place to drive innovation. This afternoon, we're going to discuss disaster recovery metrics as a means of driving innovation. Today we've got the perfect storm of dull. Metrics, always a fun one. Disaster recovery and acronym soup. The triple crown of dull, if you will. But today we'll go beyond the dull, beyond the acronym soup, and beyond traditional recovery. Today in this session we'll look into the characteristics of disaster recovery, and we'll see how to evaluate a recovery strategy to enhance our efforts and to get the most bang for our buck. Here's how we'll tackle the topic. Let's discuss time metrics, data and scalability metrics, and with that as a background, let's consider recovery strategies that optimize around specific metrics. That'll round out the time and leave us a few minutes at the end for questions. The key takeaway from this session is that considering metrics beyond recovery time and recovery point is crucial to meeting our service level agreements. Left unattended, certain characteristics of recovery strategy will cause us to miss our recovery time. So it's important we look beyond the surface. As any IT manager knows, our focus is on raising IT service levels while lowering IT costs. And the advantage to considering the metrics we'll be discussing today is it allows us to do just that. The exercise can identify ways to decrease the operational costs and per incident costs of our recovery program. A bit about me. My name is Wolfgang Gorlick. I am the Network Operations Manager and Network Security Manager for a Michigan-based money management firm. I've been with the company for 6 years and been in IT for 15. In a former life, I used to do consulting on many topics, including high availability systems and disaster recovery. My focus today is on building high performance, high available systems, and I developed and maintain my firm's IT disaster recovery program. Now we have the muscle car IT infrastructure. Being from my Detroit, automotive metaphors, they come naturally. Anyways, depending on who you ask, my firm is either a big small company or a small big company, and our IT engine is, comparatively speaking, overpowered. Like a muscle car, tight and light body, powerful engine, plenty of horsepower. For primary storage, we are utilizing a tiered fiber channel SAN. Tiers include SSD, 15K and 10K spinning disks. At a recovery site, we have a second fiber channel SAN, and the two storage enclosures are back-to-back. For hot recovery, we rely on the SAN. Storage snapshots are taken at fixed intervals and replicated from production to recovery. These then can be mounted on hardware at the recovery site and resume operations. Recovery is mostly automated, save the reboots and the validation steps. For cold recovery, we are still relying on tape. Backup tapes are moved off-site on a weekly and monthly rotation schedule. My firm has branch offices, and for these deployments, we rely on our BOB, or branch office in a box. Each BOB system has read-only domain controllers, print service, file service, and management point, and all files are replicated between the main data center and the BOBs via Microsoft Windows DFS. We are virtually all virtual. That's to say, 80% of our servers are virtual servers. Our hypervisor stack is divided up into 4 systems. The Bob is a single hypervisor computer hosting up to 8 servers at a branch office. The production cluster is connected for data networking via 10 gigabit Ethernet and storage networking by 8 gigabit fiber channel. The recovery cluster is comparable, though smaller. For rapid development cluster, we've repurposed off-lease hardware. So the ready cluster is connected for data networking via 1 gigabit Ethernet and storage networking via 2 gigabit fiber channel. And that, in sum, is my firm's technology. We're a small business with an enterprise-class infrastructure, providing plenty of horsepower for today's demand and plenty of horsepower for tomorrow's growth. As we talk today, I'm going to return to this slide a number of times. There's a few reasons for this. First, to provide perspective. It's important to view disaster recovery as part of the overall business operations. The business culture drives service requirements and service levels, and the IT group's culture and competencies drive service architecture and implementation. Business determines why, IT determines how, and perspective is needed to remember what we're recovering, the business. The second reason is that the slide captures how we view disaster recovery and business continuity. At the top, we see a continuity program as part of the daily operations and as an ongoing concern. At the bottom, we see a typical business process enabled by systems, applications, and operations. Depending on the business process being recovered, different disaster recovery strategies may be employed. Another reason we'll refer to this slide is to show the touch points. Each touch point represents a metric in the service level. Each one is a mark we need to hit to be successful in recovering. Each one, except for that pesky lightning bolt. Lightning strikes, asteroids, and jet engines falling out of the sky. Let's talk a little bit about events and impacts, that lightning bolt. One area that IT managers get bogged down in is in enumerating potential events and creating separate plans for each. This makes some sense if you're in charge of saving lives. So a power outage will be responded to differently than an earthquake or a snowstorm. But if you're in charge of maintaining IT operations, the case is much different. I find that regardless of the event, there are 4 categories of impacts. The application is down, the server is down, the site is down, or communications to the site is unavailable. Now, there can be dozens or more events, dozens. And creating a unique recovery strategy for each event will tax your time and your wallet. But practically all events cause one of these 4 basic impacts. By planning around the impact, we can simplify things considerably. Now, for each impact, there are certain specific systems and applications that will need to recover. For each system and application that needs to be recovered, there's a specific time that we have to get things back up and running. And this brings us to Recovery Time Objective, or RTO. RTO is the most used metric in disaster recovery. I mean, so much so, the rest are almost always overlooked. Something's broke, right? So first thing you're asked, how long until it's fixed? That's RTO. And since we're recovering a business process from a specific impact, there's 3 things we need to fix. Servers and computers, applications that run on them, and the business operations. The interesting thing about RTO, and indeed all the time metrics, is the trade-off between preparation costs and implementation costs. If you want to be up and operational immediately following an event, you can expect to invest heavily in redundancy and duplicate processing. Now, those investments can be skipped, but this will raise the amount of downtime, which raises the per incident cost. It's important that IT managers always understand this trade-off. It may cost a business a couple $100,000 to be down a week, or it may cost a tenth of that. The IT managers must understand the cost drivers in order to deploy the right strategy. It's the financial impact that determines the investment in reducing RTO. Now, RTO is so commonly used, it can make other metrics seem invisible. Now, you can stop if you want with RTO. I mean, most people do, but there's a whole alphabet beyond Z for zebra. So let's go beyond where others stop. Return to normal operations, or RNO. And 10 years ago, you couldn't attend a talk on backups without someone stressing restore time. Everyone was talking about it because no one was thinking about it. Everyone wanted to get their backups down to a time window, an ever-shrinking time window. And this focus came at the sacrifice of quick restores. Fast forward a few years, and we now find ourselves in the same place with RTO and RNO. It's important to know how long it takes to get everything back online in the recovery environment, RTO. But it's equally important to know how long it takes to get everything back online in the production environment, RNO. Return to normal operations, or RNO, is nothing more than recovery in reverse. In fact, depending on the recovery strategy, the steps may even be identical. Resume the system, resume the application, resume the operations, and then continue the business process. The important thing here is that we identify the metric, set the service level, have a plan, and test the plan. I'll give you two examples. Something happens, right? Server goes down. Bad port on the switch, bad cable, temperature control's gone awry, bad memory, bad main board, whatever. Too many causes to consider. So again, we focus on the impact. Server down. Assume a cluster. The RTO is moving the resource from the active node to the passive node. That is, the active node is down, passive node takes over, and RTO is how long it takes to move. Then we fix the problem. Now the server's back up, and RNO is how long it takes to move from the passive node to the active node. Here it should take about the same amount of time, seconds. I'll give you a second example, and that's site down. Power, cooling, fire or flood, some event has impacted site availability, and now the data center is down. The time it takes to resume business processes that run on the equipment is the RTO. So now we're up and running in the recovery site for hours, days, weeks. The underlying condition clears. The site's restored, and RNO is how long it takes to move systems, applications, and operations back to the recovery site. RNO is a reminder to plan for resumption and to test that resumption plan regularly. Recovery time granularity, or RTG, is the number of time points we can recover to. Let's talk in terms of backups. We all do backups, right? Right then. Imagine a business process, application set, and systems with a backup tape recovery strategy. Let's say the RTO is 2 days. Something happens, and we now have up to 2 days to restore from tape and resume operations. Imagine also that we're doing a nightly backup schedule and that the data can be up to a week old. So nightly backup up to a week old. At 7 days in a week, 7 backup jobs in our set, and an RTG of 7. Got it? All right, so why is granularity important? Well, ask any backup admin, and you'll hear stories best told around a campfire. Stories where the first backup job doesn't contain the data, the second backup job's corrupt, and the third backup job won't index properly. And then where are you? The last thing we need is to become someone else's cautionary tale. Having several restore points avoids that fate. So granularity is important, and granularity provides us with one measure of the fault tolerance in a recovery strategy. The number of ways to build fault tolerance has jumped in the last few years. And before we may have looked at nightly backups. But today we can do storage snapshots or replays, VM snapshots, and more. Continuous data protection, or CDP, gives a very high grain RTG. Any transaction can be rolled forward or rolled back. Costs more, of course, but is very attractive in high-value business processes that require recovery strategies with high RTG. Back to the big picture, all right? So an event occurs, and we have until the RTO point to recover systems and applications with data consistent as of the RPO point. The number of recovery points between RPO and RTG is the recovery time granularity. These recovery points can be generated by the system, by the application, or by operations. Now, the closer you are to operations, the better you are. System backup, okay, can be made when the application is in consistent state. Then we restore that backup, and we have additional time spends to fix the application. By contrast, an application backup may be made intraday with operations in inconsistent state. Restore that backup, and the recovered point then requires time for operations to rerun the transactions. If possible, incorporate operations into the recovery points. For example, start a day, midday, end-of-day processing. This will provide a higher quality RTG, as recovering to that point provides known good state and will require a minimal amount of rework. R&O, RTG, I mean, that gets us beyond RTO. Now to go beyond RPO. But first, what's RPO again? Recovery point objective, or RPO, is ultimately the rework. RPO is the point in time where we recover data to. So if we think back to our backup recovery strategy, and we recover to nightly backups, that means a 24-hour RPO. Up to 24 hours from the time of one backup to the next can be lost. The closer the event is to the RPO, the more the recovery strategy will cost to maintain. So if something happens and you don't lose any data, it's going to be very expensive. If you add a midday backup job to your nightly backup job, you just increased your storage costs. And the same applies to snapshots. But the farther away the RPO is from the event, the more the recovery strategy will cost per incident. Recovering a week back means redoing a week's worth of work, and that's a sizable increase in overtime paid along with opportunity costs. Now, I've seen disaster recovery strategies miss their RPO, and almost always the miss is for the same reason. The data could not be recovered. The underlying theme of this talk is to meet RTO and RPO, we must look at the underlying metrics that support these goals. To meet RPO, we must have sufficient RTG. And at a minimum, we want to use a strategy with an RTG of 2 for a given RPO. If we're restoring from a tape on a nightly backup, that means an RPO of 48 hours with 2 RTG. For my firm's top-tier strategy, we used 15-minute snapshots with a 30-minute RPO. So to under-promise and over-deliver, use multiple RTG for a given RPO. Near-time and real-time RPO is available, and that gives us some interesting tools. Near-time will lose data in flight. So Microsoft Exchange 2010's disaster recovery option comes to mind as a near-time RPO. Cut the cable between production and recovery, and only the last email or two are lost. Of the options for real-time RPO, the most fascinating one I've seen is essentially a fireproof, flood-proof, earthquake-proof safe for your data. And by using two-phase commits, I/O is written to both the primary storage and to that data safe. In the event of a disaster, the safe can be recovered, and the data can be replayed at the recovery site. So in sum, RPO is the point we're recovering to, and a recovery strategy can use point-in-time RPO, near-time RPO, or real-time RPO. To meet RPO commitment, ensure multiple RTG is in place. When disaster recovery strategies miss their RPO, the cause is usually unrecoverable data. Having several recovery points, RTG, is one way to reduce this risk. Another way is to ensure that the data is consistent at the time of the snapshot. Active Directory and databases, those are usually the ones that suffer the most when inconsistent data is restored. This then chews up valuable time to sync up domain controllers or to to sync data and transaction files. Such repair time puts the RTO at risk, so it's vital that the consistency characteristics be taken into account. Now, the nice thing about RCC is that it's near free with most storage systems. Depending on what you're using for primary storage in your backup solutions, most vendors offer a feature to group data drives into consistency groups. And the snapshot is then taken across the group and ensures consistency of all members. The RCC metric has controls that are among the easiest to implement, so it's well worth considering when you're deciding on a recovery strategy. Recovery object granularity, or ROG, is also a consideration. Take an email server as an example. If the backup solution can only restore the entire server, right? One shot, entire server, your ROG is at the server level. If you can only restore a hard drive, your ROG is at the volume level. Other levels include restoring the email database itself, file level, or restoring individual emails, item level. The operational costs will increase as the level increases because item level restores require application awareness, meaning additional backup agents and so on. ROG is a compensating control for RCC. A lack of consistency drives time expenditures on repairing applications and systems, and during this repair, it may be useful or even required to restore item level or transactional information. So it's ROG that enables this capability. Back to the big picture. The business is humming along until something goes wrong. Something happens that impacts the systems. We recover to the point in time before the event. That's the RPO. A good strategy will have multiple recovery points. That's RTG, time granularity. And a good recovery strategy, these recovery points will have data consistency, RCC. Sometimes specific items need to be recovered, such as an email within the email system, or transaction within the accounting system, or a trade within the order management system. And a good strategy will have the ability to restore at specific object level granularities, ROG. All right. We went beyond RTO and looked at the underlying time metrics. We went beyond RPO and looked at the underlying data metrics. Let's now jump to metrics used to measure a recovery strategy's scalability. Take any given disaster recovery program, and you'll see one or more recovery strategies being used. Take any particular recovery strategy, and you'll see it supporting one or more business processes. Recovery Service Scalability, or RSS, is a measure of business processes that the recovery service can support. Workflow restoration, one of my recovery strategies, calls for people to resume operations in another building, right? So the recovery strategy is limited by the number of seats at the recovery site. And we can tailor workflows such as they can be accomplished by a skeleton crew. But still, the RSS is driven by headcount. Server restoration, another of my firm's recovery strategies, calls for Tier 1 servers to resume operations in the recovery site. And this strategy is limited by the hardware at the recovery site as well as bandwidth between production and recovery. Now we can tailor the workflow such that the top tier runs on the same set of servers, and this gets us some scalability and reduces the demands on server storage and bandwidth. But still, RSS in this scenario is driven by capacity. To build your portfolio of disaster recovery, you need to be in a place where you can understand the drivers that limit that scalability. And that'll help us determine how to scale up or down a given strategy and how widely we can deploy it. Recovery Service Resiliency, or RSR, is a measure of how tolerant a disaster recovery strategy is to disasters. I mean, the last thing we need is a disaster during a disaster recovery. Data consistency and granularity RCC, ROG. These provide service resiliency. So you have multiple recovery options like server cluster, local storage snapshots, remote storage snapshots. All these also provide resiliency. Now the trick here is to build a recovery strategy such that it can continue in the face of multiple failures. The interesting thing about most major failures is that they're really the culmination of several small failures. There's usually not one big thing that happens causing everything to break. Rather, typically there are several small things that happen simultaneously that then lead up to a major failure. So a low level of resiliency may cause us to miss our RTO. For example, a strategy that relies entirely on a tape drive will not work if the drive fails during disaster recovery. Increased RSR is important to make sure that we can continue on. But of course, increasing RSR in a number of these metrics comes at a cost. The recovery management cost, or RMC, is a number that represents the cost efficacy of a given recovery strategy. Let's assume that a recovery strategy covers accounting and legal workflows. Okay, so you perform an impact analysis and determine the cost of these workflows being down for a given time period. Combined, this is your per incident cost. You then can perform an IT operations analysis and find the cost to maintain the recovery strategy. Divide the two to find our RMC. When you find your per incident cost, it's important to remember the risk costing model. Disaster recovery, it's a form of insurance. The cost of recovery strategy should be less than the expected loss. Otherwise, you're paying too much for IT. To figure out the budget for a recovery strategy, we can estimate the financial loss of the outage, and we can estimate the chance of the outage occurring in a given year. Multiply the two to find the annualized loss expectancy. This dollar amount, roughly speaking, represents the budget you should be spending on a recovery strategy that avoids the outage. IT managers, we need to know this number in order to make sound judgments about what disaster recovery strategies to employ. With that, I know we're coming up on the time for the session, so let's spend the next few minutes on a recap, and then we'll get on to discussing example strategies and answer any questions. Time metrics are RTO, RNO, and RTG. RTO is the unplanned outage. How long does it take from the time of an impact to the time business operations resume? RTO includes resuming systems, applications, and operations. Now, the longer the time, the longer the organization is down, the higher the financial impact. RNO is the planned outage. How long does it take from the time a disaster is cleared until the time normal operations have resumed? Resumption is recovery in reverse. Systems, applications, operations move from the recovery site back to the main site. Again, the longer the time, the longer the organization is down, higher the financial impact. RTG represents the point in times we can recover to, and ideally there'll be multiple points, as one or more may be unrecoverable. RPO is a point in time before the time of impact we're recovering from. RPO represents how much data may be lost, and consequently, how much time will be spent in rework. RCC is the consistency requirements of recovery strategy, and some applications do not require much consistency, like network file shares. Others, like Active Directory and business databases, require consistency across all the volumes. ROG is the granularity recovery required. At the most granular, this is per transaction, per trade, per email, per item. Some recovery strategies meet this level. Others can be successful at the volume level. So RPO requires understanding the business process, and RCC and ROG require understanding the enabling technology. Scalability metrics define how scalable and how resilient a given recovery strategy is, RSS and RSR. And RMC provides a means for cost justification, budgeting, and optimizing. We need to make sure that we're spending the right amount of money to protect ourselves. And RMC is the metric to pay attention to ensure that we're being very, very prudent and very responsible with our IT infrastructure. Some gotchas I've seen with disaster recovery programs. R&O gotcha, not planning for resumption and not testing the resumption plan regularly. So resumption, consider it, plan it, test it. RTG gotcha, not having multiple recovery points within the RPO window. My recommendation is an RTG of at least 2 for a given RPO. So if your RPO is 30 minutes, you should have 2 15-minute storage snapshots. RCC gotcha. Inconsistent data can cause your storage snapshots to be invalid. And this in turn means either missing RPO, as we roll back to earlier and earlier points, or missing RTOs we spend more and more time troubleshooting and fixing. So evaluate the consistency options from your storage vendor and the consistency requirements of the application. RSS gotcha. Not judging the recovery scalability correctly. I mean, this can lead to gotchas. For example, adding several volumes to a replication schedule, overtaxing the bandwidth, only to find yourself not getting those recovery points to the site in a timely fashion. So keep an eye on scalability and understand your bottlenecks. RSR gotcha, not testing the strategy's fault tolerance. I mean, what happens if the primary person is unavailable during disaster recovery? What happens if a communication failure occurs when you're bringing systems online? What happens if a secondary disaster occurs during your disaster recovery? A good strategy is one that can resume in the face of multiple failures. And finally, unsustainable recovery costs. A good strategy is one that is paying slightly less than the anticipated impact for downtime. Not underpaying, not overpaying. Now let's look at a couple example recovery strategies. Each strategy is intended to resume one or more business processes. Another gotcha I sometimes see is tunnel vision based on area responsibility. The developers will view DR as recovering an application, and systems admins will view it as recovering that server over there. And others may think only in terms of hot or cold sites. The following strategies are intended to recover business processes because at the end of the day, recovering the business is what business continuity is all about. So to do so, we will recover the applications the business process requires and the underlying hardware and communications that power that application. Some processes are more IT intensive than others, and some processes can be down quite a long time. Others need to be restored immediately. We want to group similar processes together and recover their technology as part of a strategy. 4 separate strategies were required for each group of processes: unavailable application, down server, down site, or down communications. As a quick aside, this can often be simplified even further because if the site is down or if communications of the site is down, the business impact is often the same. And from that perspective, the following strategies will apply to both. Here is an example strategy for a hot or rapidly recovered business process with a site down impact. There are standby servers available at the recovery site, and we need to recover in less than 2 hours to a point in time less than 15 minutes away. This requires an RTG of 3, meaning 3 5-minute snapshots within the 15-minute RPO. The application is a database and thus requires a consistency group. So we need to replay trades, so an ROG must support tray-level granularity. And then, of course, RSR is set up to allow for multiple failures. Client services is an example warm or quickly recovered business process. On a site-down impact, we can restore within 1 to 2 days. The RTG is 3, meaning 3 4-hour snapshots within 24-hour RPO. And the business process uses network file shares and applications, so we don't necessarily need consistency groups or item-level granularity. Analytics is a hypothetical cold or slow recovery strategy. Rather than have a standby equipment, we'll just purchase new servers in the event of a disaster recovery, and then we'll restore from backup tape. This will give us a low RTO, moderate RPO, with a system-level granularity. In sum, today we looked at ways to evaluate a recovery strategy. A recovery strategy is a means to bring back online a set of business processes. And a recovery strategy will include the plan, the equipment, and the tools necessary to execute the recovery. Most people will only consider recovery time and recovery point, RTO and RPO, when developing the strategies. And this is the problem. As we saw today, we must look beyond the underlying metrics that support these goals. To meet the RTO consistently, we must have sufficient time metrics. To meet RPO, we must have sufficient data metrics. And to balance the ongoing operational costs with per incident costs, to make sure we have that budget, we must have supporting scalability metrics. By going beyond, we can meet and exceed our service level commitments. At the same time, we can provide hard numbers to justify the budget or to show cost savings. By going beyond, we take our disaster recovery game to an entirely new level. Thank you for your time today. Here's my contact information if you have any follow-up.